Hey guys, Mr. B here again, bringing another math video. This one I'm going to explain the definition. So the definition of continuity. The definition of continuity. So it's always one of those topics that when I've taught calculus, people have just found really difficult to wrap your head around. So I'm going to sort of explain it in my silly terms, and that's usually what I do. I explain stuff in the most ridiculous way I can think of. So, definition of continuity has three parts. So the first part is that f of a exists. So if we have a point, x equals a, on a graph of a function, these three things have to be true. So the first thing is if I put f of a into the function, it gives me back a number, so it exists. So the second thing is that the limit as x approaches a of f of x exists. So as the limit approaches this number, as we get closer to a, then the limit actually exists. So we get an answer back for the limit. And the third thing is that 1 equals number 2. So that the value we get for f of a, the number we get back, is the same as the limit. Alright, so the same as the limit. Now, this one's fairly easy, right? Like, you get a number, you plug it into the function, you see what it gives you back. It's always this one that causes people the problem in the definition of continuity. It's finding the limit. And generally what you have to do for finding the limit is you need to think about one-sided limits. So, one of the things that you should have learned so far, if you're doing definition of continuity, your teacher should have taught you that in order for a limit to exist, the limit as x approaches, in this case, a or any number, from the right side of it has to be the same as x approaches from the left side. Alright? So those two things have to be true in order for the limit to exist. Alright, so if these things aren't true, if both one-sided limits are not the same, then this guy is not true. So you might be asking yourself, what situation won't this happen? Or will they not be the same? So if you have a graph, let me just draw a little graph, and you have, a couple different parts to it. Let's just draw. So it might look something like this, and this is the point right here, A. So I always tell my students that one-sided limit rule is like a bridge. So if you have somebody starts building a bridge on one side of a bank, so here's my bank, and then they start building the bridge, and they build it at a certain height, so here's the bridge being built, and then you got a person on the other side building the bridge, and they build it at a different height. That bridge is never going to meet. It's never going to meet, right? So that basically is the essence of the definition of continuity, is a bridge that never meets. There are other places where something can be continuous, but a lot of these questions have this. And if number 2 fails, then it's a pretty good chance that this is why it's going to fail. Is because there is a discontinuity. The 2 points of the graph are not meeting, so one's above the other. So most things will fail if the limit, say, exists, but is a discontinuity. It's going to fail with number 1. I'll give you an example of that now in a second. But if you get number 1 works, so the point exists, like this graph actually exists at this point, so whatever this value is here on the y-axis, that's the point. You can see it shaded in. Then you need to check this one. Well, we'd have to examine both one-sided limits, and then we'd see they're not the same, and this is what the graph would actually look like. Now, the other situations where you might have a failure of the definition of continuity, well, there's 2 other situations. Let me just get a new page. So these occur when number 1 fails. F of a does not exist. So that's going to happen basically in two scenarios. It's going to happen for a vertical asymptote, so this is what some people refer to as an infinite discontinuity. So what that looks like in the graph might look like this. So you got a VA, there's your VA, and let's call that at x equal to a, and then the graph might come up and go towards that asymptote, and then from the other side looks like that. So you kind of get, it goes up one way and then down the other. So that point would be actually, A is undefined. It will be undefined at that particular location, therefore it doesn't exist. There's no value for it. So therefore you don't even have to do anything. You stop at that, it's a discontinuity, it's a non-removable discontinuity, that's the other thing. Non-removable. So that goes the same for the one-sided limits. If they're not the same, it's also a non-removable discontinuity. We call this, and another way to illustrate it, my students like to call this a jump discontinuity. So jump discontinuity, literally means like if you were on the graph, you would have to jump to the next point. So it's sort of like if you were traveling this bridge, you would have to jump down to the next part. Exactly the same scenario, right? The other type of discontinuity that you would have to be concerned about is a point of discontinuity. So this point of discontinuity is like everything that you've done with limits, indeterminate forms. So indeterminate forms generally always have points of discontinuity. So when you sub in your f of a, they're always going to give you back 0 over 0. So that means that something's going to cancel. Whereas this one, if you sub in a number f of a, then you're going to get some number, I'm just going to put question mark for that number, over 0. So you're going to have division by 0. That tells you that you have a VA or non-permissible value, an NPV. Whereas in this case, you're going to get 0 over 0. So you're not sure what the value is. It's just a discontinuity. You know it's a point of discontinuity because you can remove it. This is the only type of discontinuity that can be removed. Right? So let me give you an example. If you were doing something like this, if you had f of x is equal to x plus 1, x minus 1, all over x plus 1, and you shoved in, let's say our point was negative 1. You shoved in negative 1 to this guy, you're going to get 0 over 0. But now if I cancel this out, then I can sub in negative 1 and get back a value of 2. It's important to remember that the value is not 2 though. So I tell my students when they're doing definition of continuity, never cancel anything. Always go with the original form that you have. So that's important. Never cancel unless you absolutely have to. Always sub back into the original form. That way you get what it's going to be. So there's your 0 over 0. So what this looks like graphically is very simple. I mean, you might have a graph, and all is in the graph is a little hole. Now sometimes you might see, if the teacher gives you the graph, they might define a point up here. That's still undefined. So there's a point for it, right? Or still, it's technically f of a would be defined. It would be defined by that. But the limit would not be the same as that point because now there's a jump to that point. Alright guys, so I know there's a lot of stuff going on with this video, but what you need to do is try some examples and do as many as you can. Alright guys, thanks for watching, and make sure you study the definition of continuity. It definitely will be on your calculus exam. Thanks.